In this video, we're going to go through an example of the t-test for two independent samples in Excel. We have data here for different marketing programs, sales, and then assets for different locations of a firm. We'll be using this data for another example later on. But our question right now is there a difference in sales between the East Coast and West Coast stores? The null hypothesis here would be that there is not a difference between the means of sales in the East Coast stores and the mean of sales in the West Coast stores. You're performing a two-tailed test, so the alternative hypothesis would be that there is a difference between the two means. We don't care, we don't know ex ante which way that difference is going to go, so we're looking for the difference in both directions. It could be the east that's higher than the west, or it could be the west that's higher than the east. Now, I'll be working with the full data later, so for the time being, we need store location and sales, so I'll just delete these columns to make it simpler. Now we just have the store location, which can be either East Coast or West Coast, and the sales in that particular store. So the first step is to calculate the mean of each sample, so the mean for East Coast and for West Coast locations. So to do that, I'll sort the data based on location. So go to sort and filter, custom sort, and we'll sort based on the store location. This way puts all the East Coast ones together and all the West Coast locations together. So I can calculate the mean very simply. Average. So this will be for the East Coast stores, and that goes from B2 down to B39. That is the mean for the East Coast. Now let's do the West Coast stores. So that is going to be the average of starting in B40 down to the end in B76. So we have a mean on the East Coast, the sales of 1277, and we have 1004 is the mean on the West Coast. So because we're trying to determine if there's a difference between the two, these numbers are different, but is it statistically significant? How confident can we be that this actually is showing that there's a considerable difference between these two stores? To do this, the next step is to calculate the F statistic to determine if the variances are equal. So I will go up to the data and then over to the data analysis button to select this. I'll select the fstat for two sample for variances right here, fstat two sample for variance. Pull that up, that gives me the variable 1 range and a variable 2 range to include. So I'm going to grab the variable range for variable 1. That will be for the East Coast store. So we put in the raw ones down from B2 to B39, just like we did to calculate the mean. For variable 2, we do the same thing this time for the West Coast stores. So B40 down to B76, the last observation. We did not include labels, so we won't check the label button. We'll leave the alpha at 0.05, and we'll put the output range just in this. It's not letting me scroll up, so there we go. The output range just right here on this worksheet to keep it simple for us rather than opening up something new. All right, so here we have the output for the fstat. Let's check by checking the means real quick. Here we have 1277, same thing we calculated before when we did it by hand. 1004, same thing as before. And well, let's make variable 1 East Coast and the variable 2 West Coast, so we know, so it's easier to keep it straight. And these numbers, just looking at the figures here, make sense. These seem reasonable without doing the math, just to make sure that we haven't, forgotten to select something or clicked a bunch of empty cells or anything. And again, the number of observations looking at that seems reasonable. But what we really want to pay attention to here is the p-value. So the p-value is 0.37. So we said that our decision rule was if the p-value is less than 0.05, that we would use the t-test for unequal variances. Otherwise, we would use the t-test for equal variances. So since this p-value is greater than the alpha level that we set, we should use the t-test for equal variances. We can reject the null hypothesis if there's a difference between the two variances. So Whether you use the t-test for equal variances or unequal variances, the process is going to be the same in Excel. The input's the same, we use the same data and stuff. So from your end, it looks like we're doing the same thing. Now, Excel uses a slightly different formula based on which type you select. So the answer will be a little bit different. So you want to make sure you're selecting the right one. But from your perspective, you're doing all the same things. So again, I'll go to data, that tab, and then click on data analysis. Um, we'll look at the t-test for assuming equal variances right there. Um, so here again, we have the range for the two groups. We'll select them just like we did before. So select variable 1 for the East Coast for those observations. And then for variable 2, select B40 down to B76 for the West Coast locations. Um, yeah, so we don't have any labels. The hypothesized mean difference, you can leave that blank because we're assuming equal variances. The the automatic hypothesized mean is 0, so we can, if we leave that blank, it leaves it at 0. And then we'll just choose an output range, let's say here, so that again, we don't have to open up new tables or anything. And let's just relabel variable 1 and variable 2, East Coast and West Coast to keep things simple for us. So the output here includes the degrees of freedom. We have a t-statistic of 1.71. Now we're using a two-tailed test, so we look at the p-value or the critical value for a two-tailed test. Remember, we could use either way to determine it, although we typically use the p-value just because it's simpler, much more consistent to use. So since the p-value is greater than 0.05, the p-value of the two-tailed test, which we were working on, so recognize it is 0.09. So since the p-value is greater than 0.05, we would fail to reject the null hypothesis, meaning that we observe no difference between the means. So using the critical value here at 1.99, you see that's greater than our t-statistic. Yeah, so again, we would, using either way, we would fail to reject, or excuse me, we would, fail to reject the null hypothesis, meaning that we observe no difference between the two means. So despite the fact that these numbers are different because of the variation in the sales from the individual stores, the difference is not statistically significant.